Welcome to Lesson 5 in ATE 104. In this lesson, we will discuss the topics of motion, including the difference between speed and velocity, acceleration, Newton's laws, momentum, the difference between circular and rotary motion, and centripetal versus centrifugal force. We might think of an object in motion simply as one that is moving. But a better definition of motion might be when an object is said to be in different points in space at different times, it is said to be in motion. If the distance the object moves remains the same for a given period of time, the object is said to be in uniform motion, or moving at a constant speed. If we set the cruise control on our car to 60 miles an hour, we would then be in uniform motion. Speed is how fast an object is moving or how far the object will travel in a specific period of time. Velocity is the rate of motion in a particular direction. If we make one lap around a 1 mile closed track in 1 minute, our average speed for the lap would be 1 mile per minute or 60 miles per hour. However, our velocity would be 0 because at the end of the lap we would be at the same spot we started from. This example might also help to explain the difference between speed and velocity. A pilot departed Emmettville heading for Frogstown, which was 200 miles due west. Because his plane flew at 100 miles per hour, he figured the trip to take 2 hours. But after having to divert twice to avoid bad weather, it ended up taking him 2.5 hours to arrive in Frogstown, even though he maintained a constant speed of 100 miles per hour. His velocity, however, was only 80 miles per hour due west. That was determined by taking the 200 miles he traveled due west, dividing it by the 2.5 hours the trip took to arrive at a velocity of 80 miles per hour. Acceleration is the rate of change of velocity, or how velocity changes over time. If a car travels from 0 to 60 miles per hour in 8 seconds, it is said to have a positive acceleration because its velocity continued to change over that 8 seconds. Its acceleration would be 60 miles per hour minus 0 miles per hour divided by 8 seconds, which equals 7.5 miles per hour per second. Or its velocity increased 7.5 miles per hour each second. If it took 8 seconds to slow from 60 miles per hour to a full stop, then it would be said to have a negative acceleration of minus 7.5 miles per hour per second. Newton's first law of motion states that objects at rest tend to remain at rest, and objects in motion tend to remain in motion at the same speed and in the same direction, unless acted upon by some outside force. Newton's second law of motion states that when a force acts upon a body, the momentum of that body is changed. The rate of change of momentum is proportional to the applied force. The more force, the more change. An object's momentum can be calculated by multiplying its mass by its velocity. The more mass, the more momentum. The more velocity, the more momentum. If a force is applied that affects a body's momentum, the force can be calculated by the formula force equals mass times the difference between the final velocity and the initial velocity divided by time. That formula can also be stated as force equals mass times acceleration. On Earth, gravity exerts a force on each body, causing an acceleration due to gravity equal to 32 feet per second squared. So on Earth, the force acting upon momentum becomes force equals weight times acceleration divided by the force due to gravity. Newton's third law of motion states that for every action there is an equal and opposite reaction. The lift generated by an aircraft's wings is attributed in part to Bernoulli's principle and in part to Newton's third law. Here we have a sketch of the cross-section of a wing angled to the relative wind. As the wind is deflected downward by the bottom of the wing, the equal and opposite reaction tends to force the wing upward. Circular motion is the motion of an object along a curved path that has a constant radius. The orbit of the moon about the Earth is an example of circular motion. Rotary motion is the motion of a body turning about its axis. The Earth spinning on its axis is an example of rotary motion. The centripetal force is the external force required to make a body follow a circular path at a constant speed. The force is directed inward toward the center of the circle. The centripetal force always acts perpendicular to the direction of the motion of the body. We can calculate the centripetal force acting upon an object by multiplying the object's mass by the square of its velocity divided by the radius of its path. Centrifugal force is equal to centripetal force but acting in the opposite direction. For example, the force of the rotating object exerts on a string. If we were to stand on the ground and spin a ball attached to a tether around us, the force acting to prevent the ball from flying away is centripetal force, and is applied by the tether. The force acting to prevent the tether from pulling the ball in towards the center is centrifugal force. As long as the distance between the ball and the center of the circle is constant, centripetal force equals centrifugal force.